Okay, first of all, let me introduce myself. My name is Muhammad Lesrufti, NRP001, and in this video, I will demonstrate for a question that I've been solved. So let's move on into the first question. So the first question is column conundrum. So basically, in this question, the essence of the question is just we built a self-balancing BST binary search tree and compute the sum of the node values grouped by column, where the column is defined by column x equals to right distance count minus by left distance count that which mean I will be explained later. So let's go into the code and so maybe I will explain first. So yeah, the first one we have the struct node. So we just need to define the tree node of the FL3 and then some helper function in this. So the basically in this function we just need to get the height of the node and then calculate the balance factor and then update the node's height after insertion or rotation. And then wait and then yeah, I think that's all. Yeah, basically. Oh, sorry. So first one is maybe I will explain again. So this is the struct node, just to store in the node. We get height and left, right, and then some helper function. This I'll be explained. And then we have rotate and rebalancing FL3 for these two. And then this one so for the insert into the FL3. And then column calculation, this one is for calculation using the FS, and this for the solve function in this function, and then this the main function. Yeah, I think that's all. And so maybe we can go to the test case. Yeah, so the answer is correct, same as the test case. And then we move on into the second question. For the second question, it's the Telat, yeah. So basically, for this question, it's just so basically we just need to sort the shortest path using the Dijkstra algorithm. We give in a city named A and then B for the goals or the destination, and then C for the path or how much path we have, and then we find the fastest way from the A to B, and then after we have the fastest way, we compare it with C. It is less or equal. And why we use Dijkstra? Because the graph is weighted and we want have the minimum travel time. Yeah, so basically that's the essence of this question. And then maybe we can go into the demonstrate. So yeah, maybe I will explain it first. So yeah, basically first of all we have some library of course, and then we input the variables and agency list. N for the number cities, M for the roads, A for starting city, B for destination city, C for time limit, and agency list where we adjust U, store pairs, V and W, meaning a road from U to V takes W in hours. And then for the this loop is just for the reading the road, reach each road connecting cities U and V with weight W, and then both direction because roads are undirect. And then so this one is Dijkstra algorithm. So yeah, we just need to search for the shortest known distance from A into B, and then so this one is the main Dijkstra loop in this one. And then yeah, we just need to check it is less or equals to C. If it is less or equal to C, it's gonna be print out tepat waktu, or not, it's gonna be print out terlambat. So we can go to the test case. Okay, okay, the first test is correct, and then we have some test case. Okay, yeah, so basically we have solved this question and move on into the next question. So the MST problem is just basically we just need to constructing the minimum spanning of tree, MST minimum spanning tree, using Kruskal's algorithm to connect all nodes with minimum cost. So yeah, basically we given a weighted undirected graph, and we must connect all nodes with the least cost and no cycle. If not all nodes can be connected, it's gonna be written impossible. Yeah, basically that's all. And yeah, maybe we can start by the uh, oh yeah, I will explain this code first. Yeah, so basically we made the structure for the edge and sorting logic for the repression one undirect edge from node U to node V with weight W, and then this one to set union find, yeah, parent to for the representative root of the set containing node E I, yeah, and then this one is function to find an union function, and then for the main function we have input and setup, yeah. So basically I'm sorry if I have some problem with my I'm kind of pilak. Wait, yeah, basically first of all we of course we reach number and nodes, reach all edge into a list, and then where's the Kruskal algorithm is start from this until this. So this one is for the Kruskal algorithm. So basically it's gonna be sort edge by weight from the smallest first, and then initialize each node as its own set, and then building the MST from this into this. So this one to building MST for each edge, and we try to add try to add it into the MST if it connects to different components at it, and we track the MST cost, number of edge used, and update min edge or max edge, yeah. And then this one is just for the output result. Okay, we're gonna check. Okay, so basically we've done for the sorry, this one's for the okay, so we have the exact value with the test case. And then for the last question, Job dan Adik. So basically we just constrain reachability in a graph, like how many nodes can be reached from a source within in the distant budget. So we start from a node and explore all the reachable nodes, but only if the total travel distance to the what we input. Um, yeah, we just think of it like the kid can only travel uh how far and like yeah how far they can go. And then basically we just use BFS and Dijkstra with distance limit and understanding how to limit exploration in graph and yeah and so on. Okay, that's for the explanation for the question, and we move on into the code. Okay, so the core idea using Dijkstra is to calculate the minimum distance from the start node S to every other node and count how many nodes are reachable within distance Z. Yeah, that's the idea. And then we set up an input from the cons until the until this we set up an input, and then graph representation from this until this. Read the edge and build the undirect graph, and then Dijkstra initialization. We store the minimum distance from S into node I, and then initialize all the distance into E and F except the start node S, because yeah we start from the S which one is 0, and then we use the minimum have priority queue to always expand the nearest node. And then this one is for the Dijkstra main loop with cutoff, because also this part process the nearest node u from the queue, and then for every neighbor phi of u checks first checks it is going to phi through u shorter than the current known path, and then is it the total distance less or equal than z, and if it's yes, update the distance into the phi. um Yeah, and then um, this one is for counting reachable node, loop through looping through all the nodes, and if node is not starting node and can be reached within time z counted, and then we just have the output. Okay, okay, yeah. So we have the correct answer. Oh yeah, we just have one test case, and yeah, that's all for the this question, and thank you so much